If you haven't already given me your Penn State email, please go ahead and do that. And this week we are doing confidence intervals. So I love confidence intervals. I think they're fun. So hopefully you guys, you're probably like, nope, but they're a good time. I think these are fun. So let's talk about what a confidence interval is in general. So basically it's talking about, we're trying to find reasoning for our sample to the population. So remember, all that we've been doing so far has been trying to figure out make an inference about our population based upon our sample. So this is the same idea, and it's going to be giving us a range of values that we're saying that we're a certain percent confident in about if our population parameter is within that. So this is the standard equation that we use for confidence intervals. And so the different things that we can have here, so we could have p hat for our point estimate, and then that means our multiplier would be our z star. And we can also have x bar as our point estimate, which then this would be our t star. But main idea here is just you want to make sure you understand that multiplier, and then times our standard error, which we'll actually go over on the next slide. So more specifically, these are the different parts of the confidence interval that we find out. And so once again, we have our sample proportion. So this is we're talking about population proportion specifically for now. So we have our sample proportion here, and then z star, which is our multiplier like we just talked about, and then this is the equation to find your standard error of the sample proportion here. And once again, our z star is the multiplier, so that often for a 95% confidence interval, we'll have things like, we can have things like, 2 for a multiplier. And then here, all we're trying to discuss here is that our standard deviation basically, or our standard error is the standard deviation of our sample proportion. That's why these look very similar here. And another way to write a standard error for a population or for a sample proportion would, just like we did for the population, would be this p hat times 1 minus p hat, our sample proportion, divided by our sample size, whatever that is. So that's just for population proportions, making an inference about that. And then for a population mean, the only difference here is that our standard error of the mean is different. It's we take our sample standard deviation, which is s, and then we divided by the square root of n, so square root of our sample size. So that's just different in the fact that for our equation, we're going to have our point estimate, which is our sample mean, and then plus or minus our multiplier, and then times our standard error. But in this case, our standard error is going to be this s divided by the square root of n, which is different from our population proportion or sample proportion. And then going off of that, so we were just talking about, for one mean or one proportion, but we can also go into having a confidence interval for the difference between two proportions and or two means. And basically, the only difference between these standard errors and what we did for the first two is that we want to make sure that we're using both samples here. So our first part is the first sample, second part is the second sample. And then that's the main idea, because remember, if for the ones where we were only using one sample standard deviation or one mean, we would only have this beginning part of the equation. But since we have two, we're going to make sure that we add in the second part here. And then remember, that means that our point estimate is going to be the difference between the samples, not just your sample proportion or your sample mean. And then once again, you have your multiplier times the standard error for the difference. So you want to make sure that this isn't just a standard error of 1, it's going to be the standard error of the difference between the two. And then a side note here, we'd have to make sure that our samples are independent, which means that our samples are going to not affect each other. If they do affect each other, this wouldn't really work. So in this case, you just have to make sure that if you are doing a difference between sample means or sample proportions, that the samples that you obtained are going to be independent here. All right. And so, okay, so then we have statistical significance, which basically is talking about if our confidence interval is significant or not. So we've been talking about before, if something is significant based on the p-value, but here we're talking about how our confidence intervals overlap or don't overlap. So for our first one, we have two confidence intervals do not overlap. Then we can say that there's a statistically significant difference in the two populations. So that makes sense because it's saying that the two confidence intervals don't have any numbers in common. And since they don't have any numbers in common, then we can say that we have something statistically significant, saying that they are different. So our null would be that they're not different. Our alternative hypothesis saying that there's some sort of change and that they are different. So that's where we get that from. And then, excuse me, for our second one, if the confidence interval does not contain 0, that basically means that that's also saying that's statistically significant. So these are both talking about something that's statistically significant. So if it doesn't contain 0, that means that we can say there's some sort of difference going on, because if it was 0, that means that it's contained in the interval where you're confident that the population proportion or mean is within there. So if it doesn't contain 0, that means that you can be confident that there's not really too much of a chance of there being 0 difference, which would say that there is no change. So that's the main idea there. You want to check if something is statistically significant, 0 will not be contained in that confidence interval, or if your two confidence intervals don't overlap. So those are two ways to make that conclusion. All right, so let's do some review questions. So we have our first one. So consider a random sample from a population for which of the following conditions will be the margin of error be the largest here. So read through these, check out the different answers, and let me know what you think, and we'll go over it. All right, great job. Yeah, so our answer here is going to be A, because this is the one where we have the smallest sample size and the largest confidence level. So a large confidence level is going to already have a larger, it's going to be more spread out, wider. And then a small sample size is showing that there's going to be more chance of making an error, because remember, we always want to have a large sample size. So since we have a smaller sample size here and then a wide confidence level, that means that our margin of error is going to be the largest, because remember, our margin of error is looking at like how far out, it's going to be part of our spread of the data. So that's why it would be A here. This is going to have the largest margin of error out of all of these here. So good job. All right, so here's our second one. So a 95% confidence interval for the difference between the mean head circumference of women and the mean head circumference of men is determined to be negative 1.3 centimeters to plus positive 1.2 centimeters. Which of the following statements is the best interpretation? So we're trying to basically decide statistical significance here. So let me know what you think about this one. Okay, yeah, great job. Be confident in your answer. No question marks. Good job. So in this case, this is our 95% confidence interval. It's going to be negative 1.3 and then to 1.2, positive 1.2. So remember, we're trying to look at, to find statistical significance, one way we can look at it is see if 0 is contained in the confidence interval. So in this case, 0 is contained in the confidence interval. So that means since 0 is contained, that's basically saying that, so we're 95% confident that our population parameter is within these two numbers. So that means that there's a high probability that it possibly could be 0, which would say that there's no difference. So that's our answer. B is going to be our answer because since 0 is contained in the confidence interval, we're not able to conclude that the mean head circumference differ because there is a probability that it is 0, which would mean that there's no difference there. So good job. Awesome. All right, let's do a few more. All right, a 95% confidence interval for the mean height of adult women is 64.2 inches to 66.2 inches. The interval is based on information from a sample of 30 women. Which of the following statements is the correct interpretation of this interval? So try this one out and then we'll go over it. All right, so let's go over this one. So we're talking about, so we have our 95% confidence interval from 64.2 inches to 66.2 inches. And so in this case, remember, when we interpret a 95% confidence interval, we say like, we are 95% confident, 95% confident, and then that, and then we interpret what we think we're 95% confident of. So in this case, you want to make sure that 95% confidence intervals aren't talking about the percent per se that are between the two. We can't make that assumption. We're saying that 95% of all women are between that because we're saying that we're trying to figure out that if our population parameter is contained within this interval. So we're saying that we're 95% confident that our population parameter is contained within this interval. So this doesn't mean that this is 95% of our data, because that would have to mean basically that this is plus or minus 2 standard deviations from our mean for that to be true, but that isn't always true in this case. So keep in mind the fact that we want to make sure that we're not talking about, this isn't 95% of our data, it's just saying that we're likely that this is likely, we're 95% confident of that. So that's why the answer would be C, because we're saying that we're likely about that, and so it doesn't have to do with 95% of the sample. Does that make sense? All right, cool. All right, let's do one more. So suppose an unbiased random survey was conducted to find out what proportion of Center County residents intended to vote in the next non-presidential election. For which of the following confidence intervals would it be fair to conclude with high confidence that a majority of residents intend to vote in the next non-presidential election? So it's kind of seeing if you know how to write a confidence interval. So try this one out, and then we will go over it. Okay, so let's see. So when we're talking about the majority of residents, that means that we think that it should be greater than 50%. Okay, so that's what we're looking for it to be more than 50%. So if we have these confidence intervals, we're saying basically, what we think it's going to be, what we're pretty confident that it's going to be between these two numbers. So our answer here would be C, because the entire confidence interval is above 50%. So that's basically saying that we're confident that it's within these this confidence interval here. Since we're talking about for A and B, they're talking about having these confidence intervals, but 50% is contained in there. So there is a possibility, that it is less than, in this case, it could be like less than 50%, because we're saying we're highly confident that's between these, but that also includes these. So C would be the best answer because it's completely, the entire confidence interval is completely above 50%. So we can be pretty confident that it is going to be above that. Does that make sense? Okay, yeah, main idea here is just to understand that, if we're looking for a specific, if we want to have high confidence of something being your population parameter, you want like your confidence interval to be above that, because that means then you're only, a small percent confident that it's outside that confidence interval. So this is saying that we're confident that it's within this, which everything in this is above 50%. So since these two have 50%, what if both are below? If both are below 50%? It could be. Well, yeah. So if you could have a confidence interval that was, I mean, I guess in this case, it couldn't be possible if you're using your 52% as your standard of your point estimate, because if you add anything to 52%, it would always be above 50%. So, but if you weren't using that, it is possible that it can all be below 50%, which in that case, it also wouldn't be something that we think would be positive there. All right, so great job. So basically, you guys can obviously go ahead onto the YouTube channel and watch the reviews, and then our next group review will be next week, the 16th, already at 8:30. So I think everyone gave me their email, so thank you for that. And let me know if you have any other questions. If not, you guys are good to go for tonight. Thanks for stopping by. You too.